Hi everyone, today we're going to learn about application of Le Châtelier's principle. This is tied to the learning objective from College Board that the students able to use Le Châtelier's principle to design a set of conditions that will optimize the desired outcome, such as product yield. Le Châtelier's principle can be used to reason about the effects a stress will have on experimentally measurable properties such as pH, temperature, and color of a solution. Let's look at the effect on pH. Bromothymol is an indicator, an acid-base indicator that can gain or lose hydrogen ion to form different colors. It is yellow in the acidic region and blue in the basic region. In the acidic region is represented by the symbol HIN, and in the basic region is represented by IN-. Now, when we add 0.1 molar sodium hydroxide to the equilibrium mixture, it will neutralize the hydrogen ion. The reaction will shift to the right to form blue. If we add 0.1 molar hydrochloric acid, it will increase the hydrogen ion concentration, and the reaction will shift to form yellow on the left. If we add 0.1 molar sodium chloride, it would have no effect on the equilibrium. Another effect on color, as iron 3 plus ion collides with thiocyanate ion, it forms the complex ion FeSCN2 plus. Now, this iron is yellow in color, thiocyanate is colorless, and the complex ion is red like blood color. Adding more iron chloride solution will increase the iron 3 plus ion concentration and cause the reaction to shift right, making the red color. Or adding more potassium thiocyanate will also have the similar effect of shifting equilibrium to the right, making the color red. If we add sodium phosphate, then it will form the precipitate iron 3 phosphate. As iron concentration is decreasing, the reaction will then shift to the left, producing yellow color. If we have formation of complex ions, such as adding ammonia initially to the copper sulfate containing copper 2 plus ion, will initially form copper 2 hydroxide precipitate. However, if we keep adding more ammonia, then it will cause the precipitate to disappear and a dark blue color complex will form according to the following equation. Now, if you say, where does the hydroxide ion come from in the beginning? It really comes from the dissociation of ammonia in water to form some hydroxide ion and ammonium ions. Now we add the hydrochloric acid to the complex ion. It will break it up and cause the reaction to go left. The color will turn light blue, according to the following equation. So it's really interesting to watch the shifting back and forth from a lighter blue to a darker blue. Another one is the cobalt hydrated with water in the solution, and we add chloride ion and heat endothermically. It actually forms the complex ion COCl4 minus. It is pink in color when hydrated with water, but blue in color when it is complex with the chloride. If we add more sodium chloride to the solution at equilibrium, we're actually increasing the chloride ion concentration, causing the reaction to go to the right, and color will change from pink to blue. If we add more water, and it adds up the concentration of water to the product side, and then it will then shift to the left-hand side, changing the solution from blue to pink. If we add silver nitrate, it will then combine with the chloride ion to precipitate out the silver chloride. That means the chloride ion on the reactant side is decreasing. Reaction will shift to the left, producing pink. It's very interesting to look at that. And then, because this is an endothermic reaction, we can manipulate the color change by changing the temperature. When we put the test tube in the ice bath, the temperature actually decreases. That means the equilibrium will shift to the left and the color will change to pink. If we then place a test tube in a hot water bath, that means we have a lot of heat, the equilibrium will shift to the right and it will turn blue. Actually, what I just described is your rainbow color lab, which every student will do in an AP Chem lab, and you will then make a series of test tubes containing different colors, and it's very, very beautiful. Practice problem number 1. I have ethene combining with chlorine in an endothermic reaction to form C2H4Cl2. What changes can produce a higher percent yield of the product? Because reaction is endothermic, we want to shift equilibrium to the right to increase the percent yield. We can try any one of the following. If we raise the temperature, because it's endothermic, it will shift the equilibrium to the right. If we increase the amount of the reactant, ethene and chlorine, again, it will use that up somewhat to shift equilibrium to the right to make more product. If we remove the product at equilibrium, there's not enough product to maintain equilibrium, then the reaction will go to the right and to produce more product. If we increase the pressure or decrease the volume, and the reaction will favor the side with less number of moles, therefore it will go to the right. To summarize what we have learned today, we learned how to explain the effect of stress on experimental properties such as pH, color, and temperature by Le Châtelier's principle. And then we can learn how to design a set of conditions in the laboratory to improve product yield. From the team of MLCA, we'd like to thank you for watching our video, and we hope to see you again next time.